Turning our attention now to concepts. Cognitive psychologists and philosophers like John Locke here have long assumed that concepts are the basic constituents of thought and belief. That is, concepts play a major functional role in any intelligent system, whether it's an artificially intelligent system, a human being, or even an animal. In fact, one of the major areas of research in concepts involves comparing conceptualization and categorization across cultures and across different animal species. Most fundamentally, concepts are going to facilitate categorization. They allow us to treat objects, properties, events, and relations as instances of the same type of thing. By facilitating categorization, concepts perform a number of central functions that we'll want to review. As we move through the world, our senses are constantly bombarding us with enormous amounts of highly complex information. In order to be able to process and utilize that information in effective adaptive responses, we have to break up that complex, blooming, buzzing confusion into manageable chunks of coherent information. Concepts allow us to do this through the process of categorization. They allow us to think about objects, properties, events, and relations in terms of general classes, thus decreasing the amount of information about the individual object that we must perceive, learn, remember, communicate, and reason about. This animated gift here, for example, illustrates my point about cognitive economy nicely. These bottles come in a variety of material compositions, a variety of shapes, a variety of specialized purposes, and a variety of colors. Yet we're able to recognize each new image as a bottle almost instantly without any effort whatsoever. It's because of our robust and almost instantaneous ability to categorize that we're then able to think about each instance of a bottle in terms of the properties that they share as bottles, and not so much in terms of their specific features or the differences between them. Concepts don't just limit the amount of information that we have to deal with and bundle our experience into manageable chunks. Concepts also promote cognitive economy in that concepts provide one with a general classification of experience into objects, properties, events, or relations, together with ready access to a manageable amount of highly relevant information for interacting with objects of that type, distilled from past experiences. So when we achieve cognitive economy through our deployment of concepts, it can be a powerful tool for information management. However, our concepts can fail to promote cognitive economy when they fail to include relevant information, or when they include irrelevant or inaccurate information. For example, failures of Amos Tversky's and Daniel Kahneman's representativeness heuristic look like prima facie examples of failures of cognitive economy. In the representativeness heuristic, our brains make inferences about the likelihood of objects, events, properties, and relations from samples. Specifically, the samples in these inferences are our concepts, and our measure of frequency is our measure of the typicality of objects, properties, or events given our concept. If our concepts aren't representative, then we'll have a failure of our representativeness heuristic to generate an accurate estimate of likelihood. This failure on the part of the representativeness heuristic results from a failure in cognitive economy. Though we've accessed information from past experience, that information isn't in fact highly relevant and useful for interacting with objects of that type for the purposes of estimating their likelihood. Indeed, in general, whenever we access information that proves unreliable or inaccurate, too complex or too voluminous for the purposes of generating a timely adaptive response, our concepts have likely failed to adequately promote cognitive economy. One way that we can get a better handle on the notion of cognitive economy is to use what I sometimes call the semi-symmetrical cone of conceptualization. It's just a means of graphically depicting the various components operative when we perceive something, categorize it, and then through that category access information in our memory. As noted, one important function of concepts and categorization lies in the management of information so as to facilitate the balance between the amount and complexity of information and the limitations, both of conscious and unconscious resources for the representation and processing of that information. In the best case scenario, the use of concepts facilitates quick categorization, allowing one to perceive, to learn, remember, communicate, decide, or reason efficiently by drawing upon a manageable amount of highly relevant information. As a result, promoting cognitive economy emerges as the information management equivalent of tractability in inference and decision-making. Tractable inference and decision-making strategies balance the need to complete the inference or make the decision within the time frame in which the result can matter, against the very real limitations of available cognitive resources for encoding information and processing the inference. Cognitive economy balances the benefits of more complex information against the cost of recalling and processing that information by organizing our knowledge around manageable units of information, thereby prioritizing information based upon its usefulness in past experience. For instance, as you drive down the street when you're approaching a stop sign, an incredible torrent of raw and constantly shifting information surges through your senses into your brain. This blooming, buzzing confusion of raw sensory data has no inherent and definitive interpretation. Do you see a stop sign? Do you see a patch of red, an octagon, a piece of metal? All these categories apply, and each might prove useful in the right circumstance. So we see that the world exhibits an inherent ambiguity. Many categorizations potentially apply to every object one encounters. To manage this massive volume of ambiguous input, your brain focuses upon a few salient objects and categories in your perceptions, hopefully in a manner that ideally best matches the context and your information needs. So when we have this torrent of input coming in, we have this very large opening in our initial categorization cone. And then the function of categorization is to take that immense volume of information and channel it down into this categorization of a few individual objects, properties, events, and relations. By introducing categorizations, your brain dramatically reduces the ambiguity in your sensory information, as well as the amount and complexity of information that you have to process. Now you see a stop sign. You pass through the categorization bottleneck here in our diagram, and you're in the position to access information. Your brain uses that category to retrieve a manageable amount of highly relevant information about stop signs based upon your past experiences. You get that short-term influx of information prioritized by its usefulness in guiding adaptive behavioral responses. If you have more time, you can use that stop sign category to access more information from your long-term memory. For instance, you might search your memories because you wonder if that stop sign has been there for a long time or has just been installed. Maybe you seem to recall that you were once pulled over for speeding by that stop sign, etc. If the first categorization doesn't suit your information, inference, and decision-making needs, then because of the interrelated organization between categories, you can search related categories relatively quickly and easily. You can even recategorize and begin again so that you have this progressively larger pool of information from memory that you can access given sufficient time. And in this way, the information access is prioritized in accordance with what past experience suggests is the most important information to have in formulating an adaptive response to the immediate circumstances. This turns out to be a pretty good trade-off in that the massive amount of information that you jettison as part of the categorization process can be recovered simply by reattending to the visual, auditory, gustatory, etc. input. The benefit you get by jettisoning the other information in your sensory experience is this useful transcontextual category. This category then gives you access to highly useful information, an executive summary, as it were, in relatively immediate fashion. You can use this categorization to access a greater depth of knowledge from your personal experiences via long-term memory as well. We'll finish our discussion of these three important features of concepts and categorization in the next lecture module.